In this video, I am going to discuss two integral calculus problem. The first question is integral of y minus x square dx dy over this region ABCD, which is given here in this question. So I'll not solve the whole question. Rather, I'll just give you the idea how to solve these kind of questions. I'll give you the hint. So the first thing to solve this kind of problem is to define the region. So the region where I have to integrate, and also in this question I have to be careful how to deal with the mod, that is mod of y minus x square. So let's see the region is ABCD, where this is A minus 1 comma 0, B is 1 comma 0, C is 1 comma 1, and D is minus 1 comma 1. This is my region. Now since there is a mod in the question, I have to be careful here. Now I divide this region, this rectangle, into two parts. One is I1, another is first one is I1 and second one is I2. The first part I1 is basically the region which I have shaded using pencil, is basically the region where y is greater than x square, that is y minus x square is greater than 0. And the second region is I2, which is basically y minus x square is less than 0 part, where where y minus x square is less than 0. Basically this the region which I have shaded with pen. Now what I'll do is I'll divide the integral into two parts, I1 and I2. Now for I1, since y minus x square is greater than equal to 0, that means mod of y minus x square is y minus x square. So there is no change. This is mod of y. And let's see the limits of the integration. So for I1, I'll integrate in this direction. So for I1, you can see that the region is x square to y equal to 1, and this line is and the region is from minus 1 to 1, which I have written here. So for y coordinate, the limit is x square to 1, and for x coordinate is minus 1 to 1. And similarly for the region I2, the region which is shaded with pen, for this region the limits of y is 0 to x square, because here this line starts with y equal to 0 and ends with y equal to x square. That's why it is 1. And for the limits of x, it will be minus 1 to 1. So this is what I got. Now this is just some simple calculation which you can do, and you can calculate the limit. And now let's do another more question, which is a little bit more calculative. The question is integral of x 2 plus y dy dx over the region D, where D is given as mod x plus mod y is greater than 1 and x square plus y square is less than 1. So basically this is the reason. This is the reason which I have shaded using pencil. This is the reason. And in this region I am dividing the whole region into 4 parts, I1, I2, I3, I4, for easy to calculation. Now let's see for I1, this part for I1, the y coordinate, limits of the y coordinate will be this line, then this whole circle, which is equal to minus 1 minus x to root over 1 minus x square, because recall that the definition of circle is x square plus y square equal to 1. That means y equal to root over 1 minus x square, and I am taking in the positive direction, so it is root over 1 minus x square, and it is varying from 0 to 1. I mean the x is varying from 0 to 1. So this is my I1. Similarly, I can define what is I2. I2 is basically this region. And the line in I2 is minus x plus y equal to 1. So I'll get 1 plus x to 1 root over 1 minus x square, the limits of my y, and the x coordinate will vary from minus 1 to 0. Okay, and similarly I can find I3 and I4. I3 is basically, now for I3, I mean this region, my circle will come first and then the line will come. So it is minus, and remember that since we are in the lower half region, I mean that's why there will be minus sign, minus root over 1 minus x squared to minus 1 minus x, and x coordinate will vary from minus 1 to 0 for I3, minus 1 to 0. Similarly, I can write I4 also, I4, and similarly for I4 is this region, I4, and for I4 similarly the y coordinate will start from minus root over 1 minus x square to x minus 1, and it will vary from 0 to 1. Now it is simple calculation. You can use Frobenius-Thorinus theorem to calculate the limit. Thank you.